In this video, we are going to talk about how to use trig to find some of our different areas. So looking at these, we're going to use Pythagorean theorem or SOHCAHTOA. So for this first one, the question is, do we need to use trig? And the answer is no, because we have the base and the height. So we can just plug it into a equals 1/2 base times height. So a equals 1/2 4 times 12, which we get an area of 24. Now for this one, our second one, we do need to use trig, because if we look, we don't have the height. The height goes straight down to the base, and we don't have that value. So the question is, do we need to use Pythagorean theorem or SOHCAHTOA? And for this one, we can use Pythagorean theorem. That height comes straight down, hits at a 90-degree angle, and it bisects the base. So what we have is we have a right triangle where we need to find the height. The base is 4 and the hypotenuse is 10. So h squared plus 4 squared equals 10 squared. Subtract the 4 squared over, take the square root, and we get a height of 9.17. So now that we have the height, our base is 8. We were given that. We can plug it into our formula. Area equals 1/2 8 times 9.17. So the area of this triangle is 36.68. So looking at some other examples, in these, we need to use SOHCAHTOA to find the height of both of them. So for this first triangle, if you notice, we have two inside triangles. That 46 is the base of the whole triangle, so we can't use that 46 length. The only other length is on the left side, so we need to use that left triangle to find the height. So using the 70 degrees, we have our opposite. 34 is the hypotenuse, and h, our height, is the adjacent. So hypotenuse and adjacent, we're using cosine. So cosine of 70 equals h over 34. Multiply the 34 to the other side. H equals 34 cosine of 70, so that height is 11.6. Now remember, the height goes from the vertex directly down to our base. So in this figure, our base is 46, so area equals 1/2 46 times 11.6. So the area of this triangle is 266.8. Now looking at this next one, we have a parallelogram. So to find that height, we're going to use that triangle on the left-hand side, but we don't have the angle. Our parallelogram properties tell us that if that angle B is 58, the angle across from it, angle D, is also 58. So we can write 58 in there and then use SOHCAHTOA. So H is our opposite. Our hypotenuse is a side we don't have a length. We do have our adjacent side. So we want opposite, we have adjacent. We're going to use tangent. So tan of 58 equals H over 6. Multiply the 6 over, so we have 6 tan of 58 equals H. Our height is 9.6. Now remember, for a parallelogram, our formula is area equals base times height, and the height goes directly down to the base. Now if you notice, we have two values on that base, so we need to add it together to get our total base length. So our base is 6 plus 20, which is 26, so the area is 26 times 9.6. So the area of this figure is 249.6. So looking at this rhombus, again, we need to find part of our second diagonal. So we are going to use trig. So the opposite side is the 12. Hypotenuse we don't have, and adjacent is what we want. So opposite and adjacent, we're using tangent. So tan of 30 equals 12 over x. Put your tan over 1 and cross multiply. So we have 12 equals x times tan of 30. Divide by tan of 30, and we get that x is 20.8. Now remember, for a rhombus, our area formula is diagonal 1 times diagonal 2. We just have parts of our diagonals, so we need to add. Diagonal 1 is 12 plus 12. Diagonal 2 is 20.8 times 20.8. So the two diagonals that we're going to plug into our formula are 24 and 41.6. So the area equals 24 times 41.6, all divided by 2. So our area for this rhombus is 499.2 feet squared.